tunnel is up. So let's go bring up a command line. And let's turn on a debug too. I think that might be kind of fun. Let me give you a little more real estate here. And let's turn on a debug. Let's do a debug crypto ISAKMP. And that's going to do debugging of Ike phase 1. And let's also do debugging of crypto IPsec. And that's going to do debugging of Ike phase 2. So it's going to be a whole bunch of output if it's successful. But if it isn't successful, it's also going to give us some clues as far as what might have gone wrong. So let's do our ping to 192.168.0.1. That's R2's inside address, his private address. And let's source that from 172.16.0.1. Now what we also could do is we could type ping, enter, and go into extended and specify what source interface. But if you're on an iOS that supports this, which virtually all do, it's a lot easier to do it here. And let's just do a repeat of 1. There we go. All right, so 1 ping, please. Now, yeah, that looks good. Okay, the reason I say it looks good is I'm seeing some succeed messages here. So I'm going to turn off debugging. And now that tunnels are all built, there wouldn't be all that much more debugging that comes up, but I still want my screen to be moved on me. So not to go over this whole entire debug, but let's just talk about a couple of concepts here. So let's see here. Let's go down to Ike phase 1. All right. So for Ike phase 1, they didn't have an Ike phase 1 tunnel in place yet. And so R1 identified that and says, you know what? I need to initiate this. I'm going to send over all my policies for Ike phase 1. And so it sent over, it said, you know what? I'm going to send over the encryption algorithm with triple DES, SHA, Diffie-Hellman Group 2, authentication pre-share, and I hope that's okay. And we got a response back from the other side indicating that they were. So attributes are acceptable means that the first step of Ike phase 1, the negotiation of what parameters to use, was successful. So now that we have an acceptable policy, the next thing that happens is Diffie-Hellman is run. So Diffie-Hellman is used to negotiate the Ike, the shared secret king material. So Ike happened, and that's somewhere in this wonderful content. And then they authenticated with each other. And once they authenticated successfully, Ike phase 1 is complete. So good news, Ike phase 1 is done at that line right there. The next thing to kick in is Ike phase 2. Now Ike phase 2 is called quick mode. So if you ever see quick mode, that's the beginning of Ike phase 2. So in Ike phase 2, they negotiate the parameters for Ike phase 2. So in our case here, we have the transform 1 set. We're using AES and SHA. That's all buried in there somewhere. The attributes were acceptable. That's wonderful. And they agreed to it all. They also identified what traffic is going to be encrypted based on proxy IDs. So from R1's perspective, it's traffic from here going to here. And it was a perfect match on the other side. Traffic from 192.168 going to 172.16. So that all went great. And then it came down to saying phase 2 complete, which is a wonderful thing. So now we have an IPsec Ike phase 2 tunnel and Ike phase 1 tunnel. If we wanted to see those, we do a show crypto ISAKMP SA for Security Association detail. And there's our active Ike phase 1 tunnel. So you'll notice it's active, which is great. It's using triple DES, SHA, pre-shared key, Diffie-Hellman Group 2, and the lifetime is 23 hours, 57 minutes, and 4 seconds. That means that when we negotiated it, we said it's good for 1 day, and we're now clicking off the time from that day. So if we run down to 0 and we don't need an Ike phase 1 tunnel anymore, we won't renew it. We won't regenerate it. But if we get almost down to 0, and we need an Ike phase 1 tunnel for whatever reason, it'll go ahead and reinitiate or renegotiate an Ike phase 1 tunnel with the peer. So that's the Ike phase 1. If we want to see the IPsec tunnel, we do a show crypto IPsec SA for Security Association. And that's going to show us a whole boatload of information. But specifically, it's going to show us that we're doing encrypting traffic from our network 172.16.0 to 192.168.0. These zeros at the end represent that it's the entire IP protocol suite. You can also do IPsec just based on certain protocols, like just TCP traffic or just ICMP or just GRE traffic. So you can actually specify what you want to do. It's also showing us the encryptions that have happened. Now, because I only set one ping, that one ping never made it because it triggered everything. You know how ARP sometimes will eat the first packet? Well, if there's a little delay and the Ike Phase 1 tunnel hasn't been set up and the Ike Phase 2 hasn't been set up, the very first ping of traffic might not make it as well. However, if we did that ping again and we repeated it, let's do it 555 times. Those 555 packets are all being encrypted, sent over the internet or my simulated internet, encapsulated, and they're being decrypted on the other side and de-encapsulated. So if I do a Control-C here, or a Control-Shift-6 here, excuse me, it's Cisco, I sent 269 of them. So if we do our show output again, and scroll up just a little bit, there we go. So there's our 269 packets encapsulated and encrypted, and the replies were all decapsulated and decrypted. It's a perfect number, so we're not losing any traffic whatsoever. And an SA is simply a security association, and we tag them with an SPI. So these packets, as they go back and forth between the two peers, in the layer 4 header, protocol 50, it's going to have an SPI, a security parameter index. It's sort of like a lookup system. So the receiving VPN device can say, oh, SPI, blah, 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 blah. Awesome. I know exactly the encryption algorithm to use, what shared secret keying material to use. So it can just expedite the actual lookup. Because you might have a VPN device with thousands of remote connections coming into it, and that's one way it uses to sort through them faster. All right, so if we go back to our router here and we refresh the screen, it's going to show that the tunnel is up. If we click on test tunnel, now we just tested the tunnel. So you can test the tunnel manually, and the tunnel shows up here. Additionally, if you wanted to verify one other piece of the command line, probably one of the most important commands to see the whole picture is show crypto map. The crypto map is amazing. It's going to show you exactly who the peer is, what the access list that's being used for cryptography, the contents of that access list. It's going to show you the transform set that's currently in use. It's our set, and here's the transforms for Ike Phase 2. It also shows you where the crypto map is, or where the interface is that's connected to the remote or untrusted network, where traffic, when it goes through, will be checked. If you want to look at the Ike Phase 1 policy, you show crypto ISACEMP policy, and that will show you the Ike Phase 1 policies in use. And here's our Ike Phase 1 policies. So triple DES, SHA. Wow. Okay, now, see, this is the one that it put in. It put in this guy, and we put in this guy. So SHA was first on the list, and then we have MD5. Let's take a look at our Ike Phase 1 policy again. And it is using SHA. Okay, so unfortunately, because it pushed out two policies, had the built-in policy that used SHA versus our MD5, these guys negotiated SHA because it was the highest, or it was the first priority checked. So if we go back to take a look at this real quick, just if you're working with this, wondering why is we getting that result, because if R1's the initiator, he sent all of his Ike Phase 1 policies. He sent this guy and the other one. So I send two policies over. The other router 2, gets them both and starts looking at R2's highest first policy, number 1. And if it's a match, he goes for it. If it's not a match, he'll then go to the second one. So let's do this. Let's go over to R2. In fact, let me show you in the interface how to do that. We're on R2 right now. Let's go down to the VPN section. Here's the VPN components. Here's IPsec. So here we have our transform sets that we created for Ike Phase 2. Here's our Ike, which is referring to Ike Phase 1, Ike policies. And you'll notice that we have two policies here. Policy priority number 1 is SHA. Let's delete it. All right, so now policy 1 is gone. And what's going to happen if we reestablish this tunnel is that R1 is going to send over both policies still, but because the receiver R2 only has one policy with MD5, Group 2, and Triple DES, it will say, yep, I'm going to pick that one. So let's renegotiate this tunnel. So to do that, now this is also to save your config, you can just say write startup configuration, confirm, and that will save it. We should probably do that to the other guy too. But let's go back to R1 and let's reinitiate the tunnel. We'll do a clear crypto IPsec. Let's do clear crypto SA. And let's see if I don't think I have debugging on anymore. All right, and let's do a show crypto ISACamp SA detail. Okay, and that's active. We'll do a clear crypto ISACamp SA. All right, so clear. Oh, that was show. Sorry. One more time. Clear crypto ISACamp. Enter. All right, so there's clear crypto SA, which gets rid of the Ike phase 2, and there's clear crypto ISACamp, which should get rid of the Ike phase 1. Okay, so it says it's deleted. So basically this is not in use anymore. So if we generate new interesting traffic, see that was the old one using SHA. So because that's been deleted, if I do new interesting traffic, go back to our ping. Let's just do, we'll do 5. That'll work. So you'll notice that the first one didn't make it, and that's because of all the negotiation that just went on in the background. But now, because our Ike phase 1 policy has changed, we now have, this is our old one that's deleted, and here's our current one that's using MD5. So I just wanted to confirm that what we thought we were getting from our policy, we actually are. So it also gave us a wonderful opportunity to go into the interface and identify the components for the IPsec. So our Ike phase 1 policies are here, the Ike phase 2 policies are here, and the details for the crypto map, which is tying it all together, is here. So the crypto map being applied to the interface says, if traffic matches the crypto ACL, your peer is going to be this peer across the road, and the transform set you're going to use is the transform set right here, phase 2. All right. So I believe we've covered the objectives here in this lesson for IPsec. Let me just take a look. Use Cisco Configuration Professional to create IPsec site-to-site VPN tunnels. Yes. And test and verify. So we've verified from the command line, also from the GUI. One last thing we could do is under the Monitor tab, under Security, under VPN Status, IPsec Tunnels, you can actually watch it here as well. So it has some monitor screens for encapsulating and decapsulation. And if we threw a whole bunch more traffic through it, which we're going to do right now, so we'll repeat it a whole bunch of times. I'll stop that after the demo. So now that we're generating many packets, this should go up. So every 10 seconds by default, these numbers should increase. And there's also graphs here that you can resize if you need to, that are also showing the encapsulation and decapsulation of packets. So we're finishing packets at a pretty fast clip here, and we'll give it 10 more seconds to do an update. So we can see the numbers jump. So 576, and there's 755, and we can just watch that all day long. So I appreciate you watching. Thanks for joining me for IPsec VPN site-to-site tunnels.